Great. Frank, thank you very much for that kind introduction, and thank you all for being here. I have a rather challenging task of summarizing some findings from 9 new empirical studies in a rather short period of time. So I will have to skip through some of my motivation slides and present you some results and some real key details on some of these studies. First up, I just need to acknowledge that this SPIA, the Standing Panel on Impact Assessment of the CGIAR, has been responsible for kind of coordinating this work, but really the credit goes to a number of research teams, and the lead authors on each of these studies are acknowledged here. We've been very fortunate to benefit from input from a number of highly qualified reviewers on this work, and we're grateful to our donors for the financial support. So here's my outline. I'll briefly introduce why we've undertaken these studies, talk about how we prioritize what we focused on. I'll give you some key headline results, and I will lead through, spend a bit of time on 3 possible issues that I think we need to think further on with regards to this research agenda going forward. So the CGIAR Standing Panel on Impact Assessment, just to introduce us, Karen is the chair. We're very fortunate to have one of Karen's predecessors in the room, Derek Biley. Doug Gollin, also previously chair, now a member of the committee, and J.V. Manakshi at the Delhi School of Economics. Provide the kind of intellectual leadership on impact assessment in the CGIAR, and then a number of us, Nancy Johnson, Lakshmi Krishnan, who's here, and myself are in the Secretariat organized out of the FAO in Rome. We also have a number of, this is a relatively new innovation for us, we have a number of postdoctoral researchers that are being hosted by CG centers in countries that are of key importance for carrying out impact assessment and being the liaison between SPIA and the CGIAR. So I'm presenting a number of adoption studies today on sustainable agricultural practices. We also have a kind of impact assessment portfolio here, and if any of these topics are of interest to you, you can find materials on this on our website or through talking to us after this presentation. But I will focus in not on impact, but specifically on a rather modest task of simply getting decent data at scale on the adoption of a set of agricultural practices that have been widely studied in the CGIAR. So this is simply just to explain that I don't mean to represent the entire NRM research agenda, and Frank gave a really nice introduction and overview to the range of different things that the CGIAR does on natural resource management. And we are simply providing some data here about adoption because it's a necessary condition for having impact from research that has focused on these practices. And we think that the value of information is high from simply having better data about the adoption of these practices. So how did we go about carrying out such an effort? There's a kind of large universe that we could have focused on of possible combinations of agricultural practices in different countries, and so as a sort of stock-taking exercise, we simply searched through annual reports, and there was also what's called the performance monitoring system of the CGIAR, to look at claims about adoption. So claims, this is basically predicated on the assumption that if researchers think that there has been successes in extending technologies to farmers and having them productively use them on their farms, they would have a strong incentive to claim that success in this system of reporting through the previous decade. So we kind of drew up a database of claims of adoption. We did some sort of prioritization exercise based on some scoring of how interesting we thought they were to us. And we came up with a short list of 6 practices in a number of countries, which is shown here. I will skip forward a little bit here through what we further did on prioritization, which was kind of a hybrid model, competitive collaborative, where we initially put out a call for expressions of interests related to these practices, for people to opt in who are interested in carrying out such a study. We brought them together in a workshop, and from that we defined a number of work packages which then were subjected to proposals for which were then subjected to external review. So the final set we have here, and hopefully the bold can show up. So we have agroforestry in Zambia, alternate wetting and drying in Vietnam. We have a number of studies in conservation agriculture in East and Southern Africa, but also of zero tillage specifically within that package in India and in Mexico. We unfortunately didn't get good studies proposed to us on cocoa ICPM, so that one fell out. We have some studies on looking at microdosing of fertilizer in Zimbabwe and Niger, which Niger is underlined because it wasn't part of our original kind of intelligence gathering. It was felt that there was a story there. And similarly, integrated soil fertility management in 3 countries in Sub-Saharan Africa. So I don't want to assume complete familiarity with those studies. I thought it was worth having a slide simply on what are the characteristics of these studies. So within the large realm of things that are done in agroforestry, in particular, we are looking for adoption of a particular, it was called a fertilizer tree. This is a species Phyderbia albida, which has this really nice property of fixing, it's a leguminous tree. It fixes nitrogen, but sheds its leaf in the rainy season, so it doesn't compete with crops. This has been the subject of a lot of work carried out by IFPRI through the 90s and 2000s. Alternate wetting and drying, which is essentially a water-saving practice, which IFPRI and partners have been looking at for some time. Conservation agriculture is composed of 3 component practices: in combination, zero tillage, the permanent soil cover through either cover crops or residue being retained on the soil, and rotation with legumes. Fertilizer microdosing is the application of small quantities of fertilizer. Think of a bottle cap, and these are microdosed either during planting stage or several weeks after initial plant emergence. And integrated soil fertility management. And so all of these practices are in some sense observable. We can either through a survey or through, in some cases, remote sensing, detect whether a farmer is using this particular technique, and they have been the subject of a lot of research effort over the past 20 years by the CGIAR. So the studies are, this is to give due credit to the authors. We ended up with a number on conservation agriculture. There was a lot of interest when we took this to the market, when we advertised in our call for proposal. There's a lot of interest in carrying out further adoption work relating to conservation agriculture. We ended up with a number of studies on that. We have a study on microdosing, a single study on microdosing, on agroforestry, alternate wetting and drying, and integrated soil fertility management. So in the interest of time, I will simply present a very summary view on what we find. In India, we find this is the data for across the Indo-Gangetic Plains in 4 regions. We find adoption of zero tillage at relatively low levels, although Punjab remains at a more promising level, and that is work. The Mexico and India studies relate to each other. There was a lot of interesting remote sensing work that was carried out in the Mexico study, which then fed into an application in Indo-Gangetic Plains. And we see for these other combinations of practices in different countries, using different kinds of methods, relatively low levels of adoption of conservation agriculture, which has been a topic of a number of relatively heated debates about the appropriateness of this technology, particularly for Sub-Saharan Africa. And so we feel like these data can potentially help to resolve some controversies in the literature there. And then for other practices, similarly, we found in Zimbabwe actually the spatial pattern of dosing that fertilizer to be adopted, but but in rather large quantities, so didn't necessarily meet the micro part of the microdosing equation. You talk to an agronomist, Bernard van Loo, says that's fantastic, that's what we need. We need more fertilizer to be applied to this. So it's not clear that that's a bad finding at all. Agroforestry, we see some level of these fertilizer trees still remaining long after IFPRI left Zambia, but sometimes only a single tree growing on a plot, and very, very little kind of full adoption of the intended planting practices around the plots that had been extended to farmers across a large geography. Alternate wetting and drying, our numbers are less certain there. I can go into that in discussion. We tried an SMS survey for collecting data about integrated soil fertility management. Unfortunately, that was very highly selected. We only had young people respond to our SMS survey, which was not representative, so I'm unable to present those results, but it was very useful learning about the limits of some of these new innovative methods. We have more promising results there for Kenya. So I'm almost out of time, but I wanted to leave you with 3 thoughts about what I think some of this stuff means. I think there's lessons in terms of the nature of innovation itself, questions about representativeness of data, and some thoughts about an experimental agenda going forward, research agenda on constraints to adoption. So Rogers, 1962, is one of the most widely cited social science books across all social sciences about diffusions of innovation. Has a scheme helping us to think about how innovations diffuse through a population of users, and has the following. And in particular, when focusing on the nature of the innovation, talks about the relative advantage, what are essentially the private benefits to the potential adopter, and then these other characteristics or attributes of the technology, how compatibility, how easily does the innovation fit in with what's currently done on the farm? How complex is the technology? Is there a lot to learn, a lot to manage? Are we expecting a lot of farmers to actually take this stuff up? Trialability, can farmers experiment a little bit on part of their plots, or do they have to make a commitment? Is it lumpy? Do we have to do everything at once or nothing? And observability, how easy is it to observe what others are doing, to learn from it, and even to also learn from your own experience? So this is very preliminary, but sketching out in terms of the different practices that were the subject of these studies and thinking in terms of these various criteria. Really, there has to be a question here. The standing hypothesis has to be that there isn't necessarily a strong enough private advantage in this top level to overcome some of these fairly significant obstacles further down this table, right? There has to be something really driving. In the absence of an incentive, a financial incentive for a farmer to adopt this, we will see low adoption. A quick point on representativeness of data. In the past, we were very frustrated, and there's a couple of papers by colleague Cheryl Doss, who highlights the problems of highly selected samples for the single purpose of demonstrating that adoption has taken place, with no real kind of clear relationship to the underlying population, which will have the tendency to kind of upwardly bias our estimates, because you simply can't unbundle the promotion effort from farmers' own long-term behavior. We've gone to the rather opposite extreme of looking for representative samples wherever possible across large geographies, because this has greater stability and policy relevance in the long run. But in this workshop that Frank's been introducing to you all, we've been talking about whether there's some intermediate here where are we able to reliably identify the recommendation domain or the subset of farmers that ever could potentially benefit from this practice. And actually a truer reflection of the adoption rates would be in expressing those. It's a very challenging thing to do, but it's a very valid critique of what we've done. And finally, I just mentioned that obviously a reasonable hypothesis is that the practices don't provide a private return, but it could well be that there are significant constraints to adoption. And there is a very interesting growing empirical literature looking at whether supplementary interventions can help farmers overcome constraints, either be it failed credit markets or information about the technology. And so colleagues in the Agricultural Technology Adoption Initiative run out of UC Berkeley doing a lot of work in this area, and it's a very lively and interesting field of research. So with that, thank you very much.